States of matter. See, the word matter we have learned in class 7 itself, or maybe in lower classes also. Is it not? So, can any one of you define what is matter? Don't keep quiet. Hello?
Anything that occupies space is called matter.
No, not yes. It is perfectly correct, but you have to use one more word, which has mass and occupies space is called matter. Is it not? Huh? Matter is defined as anything that has mass and occupy space. Okay, so this is matter that you know. Very nice, you know it, but it must have mass. Now, classification of matters, that also you know. So, Mallika,
Yes, sir.
are you still in Guwahati?
Yes, sir.
ওরা কি আর গুয়াহাটি থেকে আসবে না নাকি? ঠিক করে যে দিন হয়ে গেল।
Yes, sir.
So, what is this classification? How many types of matters are there?
3.
Yeah, it is 3, but actually now it's being classified into 5 categories. I think you know. What is this? Gas, liquid, solid. Now, can you tell me the 4th one?
Plasma.
Very nice, very nice, very nice. Plasma. And 5th one?
Einstein-Bose condensate.
Bose-Einstein condensed state. Okay, so we are not going to discuss anything here. This also we'll discuss in class 12, and we are supposed to discuss this one in class 11, but because of the pandemic situation, board has removed this liquid. Okay, but anyway we'll discuss, because pandemic state should not debar us from our scientific knowledge. Scientific knowledge does not disappear with the situation. So anyway, please write it.
Sir, done.
Okay. Now, what decides a matter should be in gaseous state, liquid state, and solid state? What decides? Who decides that you will exist in liquid and you will exist in solid, or you will exist in the gaseous state? Who decides? Any idea? No idea. Guess. It is the intermolecular forces of attraction. Intermolecular forces of attraction. Okay. So let us know something about intermolecular forces of attraction. Okay. There are certain forces that condense matter. Okay. These forces can be both bonding forces and non-bonding forces, which are called intermolecular forces. Okay. These forces are also known as van der Waal. See, V is small, huh? Van der, this is capital. Waals, forces of attraction. Okay. See here. Oh, sorry. I'll not write. No. I'll remove this one. Okay. Now what I'll do? See here. What does it say? These forces can be bonding forces and non-bonding forces. Huh? See here. What is the bonding forces we have here? This you know now. What are the bonding forces we can have? Bonding forces we can have here. কি হবলো? We can have, that is electrostatic forces of attraction, which is also known as ionic bonding. Ionic bonding. Alright, okay. So these exist in what? What we say now here? Exist among what? You know it salts. Example what? Na plus Cl minus. See, Na plus and Cl minus ions have come together by their to replace their charges. So they are oppositely charged ions are attracted to each other, by which they have become a solid mass. Okay. Second is the covalent bonding, by which the atoms, by which atoms combine with each other to form molecules. But mind you, in this case, this type of forces exist only within the molecules. This type of forces exist within a molecule. That is, it is not being extended outside. Here we call intermolecular, but these are not intramolecular, this is intramolecular. This type of force exists within the molecule. So this we can say intramolecular. Intramolecular. All right? Right.
Sir, done.
Non-bonding forces. See, in a society is being made of many families. Okay. Within the families, you have a relationship, what we generally call it blood relation. But within the families, in our locality, we have so many families, our houses are there, but we interact with each other. We respect, we love, okay? Yeah, we have a relationship. But with other families, we do not have any blood relationship. So these are non-bonding forces. Within the family, we have bonding forces. All right. So now, second one is the non-bonding forces. These non-bonding forces are known as intermolecular forces. So you can write intermolecular forces are the physical forces which act between or among the neighboring What is the spelling of neighbor? N-E-I-G-H-B-O-U-R.
BOR.
Huh?
BOR.
B-O-R. Yes.
Sir, BOUR.
So BOUR.
My initial was correct only. Neighboring molecules. These forces are weaker than bonding forces because they only stay together. They do not form any bond within them. What we can write now here? Intramolecular force. These forces are also known as van der Waals forces.
Sir, done.
Okay. Now we'll try to see how many types of van der Waals forces or intermolecular forces are there. Okay. Types of intermolecular forces or van der Waals forces. Okay. One is called dispersion. Forces or London force. London is the name of a person. London force. Okay. Second is dipole forces. And third one is called dipole induced dipole forces. See, often you forget. If anyone asks you how many types of van der Waals forces are there, I'm just giving you a shortcut. I told you that you are much more brilliant than me. I'm not as bright as you. Then how to remember so many things in science? See, how many words are there in van der Waals? 3 words are there. VAN, DER, then come Waals. So three words are there, 3 forces are there. Remember like this. So now, here I'm going to explain, I'm not going to write. It is there in your book. And I told you that after a few days, I'll try to send the some notes on the different chapters till now, which I have taught. I'm still writing it. Okay. So maybe by the end of this month, you will get it. All right. So what is? So first I'll start with dipole because it is easy for us to understand. Dipole. Dipole is what? That is, I have taken a molecule, AX. Why I did not write B? I'll tell you why. See here. Here A is an element with lesser electron activity. X is an element with very high electron activity. So we know once the bond formation takes place with an understanding that this electron will be equally shared by both of them. But you do not know the nature of human being. Huh? So same is the case of the element. After the formation of a bond, what happens? As X is having higher electron negativity, X is going to pull this electron near to it. Then this poor fellow A cannot locate his electron nearby. So it develops an electron deficiency. And in this case, there is a higher density of electron because it has taken its own electron along with the electron of the A. But mind it, the bond did not break like ions. They did not break. So what should I write? I have to indicate by electron deficiency is always being indicated by plus, and electron density is indicated by minus. Why did I write del and del plus and del minus? That is, now here this did not break it as A plus and X minus, which happen in salts. It did not break, but bond is highly strained. So this type of molecules are called polar molecules, and they have a dipole moment. So what is going to happen? In this case, you will find this type of molecules where electron deficient species goes nearer to an electron rich species. So this type of attraction is being developed within them. By that way, they come closer. See. It is like this. So all the molecules will come closer to each other. Mind it, they did not develop. They did not form any bond. But they have come closer so that the electron deficiency of this A can be partially neutralized by X. All right. See, you will find in your house, you are not earning. So whenever you have the deficiency of your resources, then in that case, you take the help from your father or mother. All right. So this type of mutual sharing of our happiness and grief that has made a family strong. So this type of forces of attractions within the molecules are called dipole interaction or dipole forces. So what type of molecules will show us dipole interactions? All the polar molecules, polar molecules show dipole interactions. Now, what is the magnitude of dipole interactions? Stronger the dipole moment, stronger is the force of attractions. All right. When you find this dipole moment is high, then the attractions will be stronger. And in that case, you will find the molecule will come closer and closer. When the molecule come closer and closer, in that case, from gaseous substance, it will become liquid. And from liquid substance, it will become solid. Because a large distance exists between the gaseous molecules. In liquid molecules, distances are less, but they do not touch each other. See, because of that, you can put your hand inside a liquid substance. But in solid substance, you cannot put your hand inside because they are touching each other. So in that case, stronger the dipole-dipole interactions, the phase of the or state of the matter will change from gas to liquid, liquid to solid. So this is called dipole-dipole. Okay, now see here. What is dipole? Induced dipole. Before that, let me tell you a simple thing which you observe right from your childhood here. Okay, see here. This is a magnet. This is a magnet. And you have taken a piece of iron, which is not magnet. Huh? So what happened? When you bring this magnet, this one near to this, then you find these also now behave as a magnet. This also now behave as a magnet. Now you will find this is also going to attract the other metals. All right. So this is a magnet, but this is not a magnet. Now it is also behaving like a magnet. In this case, what do you call it? We call it, it is induced magnet. Induced magnet. All right. So in that case, similarly, suppose you have brought, there's a molecule is there, which is highly polar. And into that you have added a molecule which is non-polar. Let me take B. See, why do we call it non-polar? Because even if they are electronegative, both of their electronegativity is same. So the electron from the middle of the bond will not be displaced any side. So it is a perfectly neutral molecule. Perfectly neutral molecule. So when you bring it near to this, see, when this comes near to this one, what is going to happen? Okay, let me write it like because it's octet. If you don't understand, immediately tell me. See, so when it is like this, see, when this comes near to this, look now what happened. This, in this case, see, this when you bring the B near to this, there's a repulsion takes place between the electrons. So to avoid repulsion, what will happen? To avoid repulsion, this electron will now shift to this side. So once it shifts to this side, see here, the molecule which was non-polar now becomes polar because the electrons are driven in this way. So in that case, what will happen now? It will be like this. That is, you have induced polarity to a non-polar molecule. By that way, a new type of attraction develops within them. Because of this, you'll find they come closer. So this is called dipole. This is a permanent dipole. Induced dipole. See, we have induced a dipole. By that way, the molecule develops attraction for each other. So it is called dipole, induced dipole. That you have seen in your classroom. You will find that you are sitting by the side of your classmate. Maybe the classmate is very much fond of talking. So she started a discussion. Initially, you keep quiet. Then you also got tempted to talk. Then you also start talking. That is, it is being induced to you. And by that way, a discussion starts. Is it not? So the same thing you find is called dipole, induced dipole. Example which I can give you. See here. No, I mean, you can enjoy. Okay, now see here. See. Water is a highly polar molecule. Water is highly polar molecule. Because you have a large difference of electronegativity between oxygen and hydrogen. And if I take chlorine, see here, chlorine is a non-polar molecule. It exists in gaseous form. Okay? So I have told you, when you want to dissolve something, we have to go for a very famous saying, we call it like dissolves like. Like in English, there is a phrase is there, we call it birds of same feather flocks together. So here also, in that case, you will find this non-polar molecule is not supposed to interact with the water molecule to get dissolved. But we find the chlorine is soluble in water. Why it is soluble in water? See, same thing. When water molecules come near to this time, the electron, this from the chlorine moves in this way because of repulsion. That way, what happens now? Now the chlorine molecule get polarized. So due to this induced dipole forces, chlorine goes into solution. Any doubt? Anything which you could not understand?
No, sir.
So it is clear? Dipole, induced dipole?
Yes, sir.
Okay, good. Nice. Okay, now we find this first one is dispersion or London forces. This type of forces exist in those molecules which are perfectly non-polar. Perfectly non-polar. But still we find the non-polar molecules also exist in liquid state and gaseous state. I told you that in gaseous state, attractions are minimum or no attractions. Because of that, you will find the gaseous molecules, they remain far away from each other because they do not have any attraction with each other. But still, those gases can be liquefied and it can be made solid. But there are various non-polar molecules are there, which you find it is in the liquid state. Take the example. You have not seen them. CH4 is a gas that you know. Is a gas. But suppose when you go to C5H12, it's called pentane. C6H14 is called hexane. Dear, these are the substances which makes petrol. Okay, so petrol is liquid or gas?
Liquid, sir.
Liquid. Okay, so these are liquid. Okay. Now, suppose you have gone to C18, H38. Okay, this is, you get a solid. That is the one which you used in your house as paraffin. Paraffin you have seen.
No, sir.
Well, why should you see? Exactly. Now I think this one you have seen. We call it petroleum jelly. Have you seen this one, petroleum jelly?
No, sir.
Right.
Yes, sir.
You are using profusely during winter. Tell me, who has seen?
So me.
Tell me, what is the name?
So Vaseline.
Vaseline.
Very nice. See, dear, Vaseline is the name given by a company to the petroleum jelly. So Vaseline is not the name of the compound. Vaseline, this name is being used by Palmolive company. Its actual chemical name is petroleum jelly. Okay, like you are a lady, but your parents have given a name. Some may be Najia, some may be Mallika. All right. So see here, but these are all non-polar molecules. Why this is gas and why this is liquid and why it is solid? But they are all non-polar molecules. They have minimum attraction for each other. Then why they have solidified? Why? See, in gaseous substance, some molecules are like this. Air is gaseous, because of that we can pass through. Okay? In case of liquid, they are like this. So within that, you can put your hand. But if it is, say, take the example, suppose, see, maybe in future, you may have a swimming pool in your house. How many of you want that you should have a house with swimming pool? Hello.
So me.
Yes. So you can take bath. You can jump in swimming pool. But if it is suppose you have settled in a very, very cold place, that is by December, your swimming pool is frozen. If you jump into the frozen swimming pool, what will happen? Huh? What will happen? You see that
Sir, the ice will break.
Ice will not break. You will break. Just look at the cartoon of Tom and Jerry. You will find what happens to the Tom. All right. So in this case, see, one is touching the other. So this is solid, this is liquid, this is gas. Why does it happen? Let us see. Why the nonpolar molecules? What type of forces are there in nonpolar? Okay, see. So let me draw a molecule. So this is the nucleus. Okay, I'll write here N plus, means is N number of protons are there. And say there are electrons are there. One, two, three, 4, 5, 6, 7. See, in this nonpolar molecule, electrons are homogeneously distributed. But mind it, electrons are not static. They are continuously moving in clockwise or anti-clockwise directions. When this type of movement goes on, a time comes that you will find that electrons, most of the electron has shifted in one side. So let me draw it again. Yeah. My drawing is very bad, please excuse me. So these are the normal stage. But in that case, electrons are moving. It may happen that you will find maybe at a certain time, this electron, most of the electron has moved in one side. So to neutralize this force, what will happen? There will be the displacement of positive charge will take place inside this. Nucleus will shift little bit to balance it. So now see, this is nonpolar. Okay, this is nonpolar. Now, is it not polarized now? Because you have found that with one side more negative charges are there and positive charge has displaced in the opposite direction. So what we will write now here? We call it polarized. See here. Now it has become polarized molecule. Okay. And nearby it is still now, it is nonpolar. So it is a nonpolar molecule. See. But as this molecule is nearer to this, immediately it induces polarity into this nonpolar molecule. So now see here. This also has become now see. This also has become polarized. This also has become now polarized. By that way, the molecule has come closer. After some time, this will be all right. So this is the one which is now going to polarize rest of the molecules nearby. So for a fraction of a second, certain molecules get polarized because of the unequal distribution of electron within the atom or the molecule. And that induces polarity into the nearby nonpolar molecules. So such type of induction of the polarity into the nonpolar molecules bring them closer. These type of forces are known as dispersion force or London force. I'll give you a simple example. Often you have seen in TV. Say there is a demonstration, mass demonstration is there in certain places. Why suddenly the crowd becomes violent? You'll find 1 or 2 or 3 persons. They came with a bad intention. They wanted to create some problem there. So they will give you some highly inflammatory speeches, and it may happen 1 or 2 or 3 of them will throw some stone, then they will disappear. Immediately the public anger spreads. But the person who has thrown stone by the instigation of others, he does not know why should he throw the stone. He is not supposed to do. He is a normal civilian, extremely well-behaved person, but he does it. Okay, same thing happens here. So this type of effect happens in the nonpolar molecules. Such type of interaction is known as dispersion force. What is the meaning of dispersion? Dispersion means spread. So this is called dispersion force, and as it is being explained and defined by London, so it's called London forces. So all types of nonpolar molecules, they see, irrespective of any molecule, polar or nonpolar, all of them they have this inherent dispersion or London forces. Why should I say inherent? Because every person we are born, some will be violent, some will be cool, but you will find every person has emotions. It is the emotional disturbances which changes our property. I may be permanently or maybe for certain time. So this is called dispersion or London forces. Now, the magnitude of the dispersion force and London force depends upon the size of the molecule and number of electrons. See, if the molecule is very big or atom is very big, in that case you will find the nucleus will be far away from the valential electrons. All right, in this case you will find the effect will be maximum, because if the atom is small, then proton will not allow the electrons to move in any way they like. But when the distance is more, then the nucleus cannot control them. In that case, they get easily polarized. So you'll find, I'll give you a simple example. Take the example of fluorine and chlorine. They're gaseous because their size is small. When you go to bromine, the size increases. In that case, you'll find bromine exists in liquid, and iodine is the largest size. In that case, distance of the electrons, valential electrons, and the iodine nucleus is very, very far. So it can be easily distorted. And in that case, magnitude is very, very high. And in such case, you will find iodine exists as solid. So these are the story of dispersion force and London force. See, I give an example of methane. Methane are small molecules. So in that case, dispersion is very weak. They exist in the gaseous state. When you go to pentane, hexane, number of the carbon molecules are increasing. In that case, you'll find their molecular orbitals are getting away from the nucleus. So in that case, distortion has taken place, and it is existing in the form of liquid. But when you go to large hydrocarbons, in that case, you'll find here the distortion is very, very high. So in that case, the magnitude of the intermolecular forces of attraction it becomes more they exist in solid. So it depends upon the mass. When the mass is more, size will be more. When the size is more, the shape also will be more. Sorry, the surface area of the molecule also will be more. In that case, larger the, please remember, larger the surface area, more is the attraction. And more is the attraction, you'll find those type of substances will now move from gaseous state to liquid state and liquid state to solid state. So now we are going to talk something about, see, intermolecular forces brings molecule closer. But we have found the solid, when if you heat it, it becomes liquid, and when liquid you warm it, in that case they go to the vapor state. All right. So we find that intermolecular forces of attraction is decreases when the temperature is increased and increases when the temperature is decreased. That is, these two forces are operating in opposite directions. So in that case, you'll find the heating, or we call it the thermodynamic forces. Thermodynamic forces are acting opposite to the intermolecular forces of attraction. See, whenever the molecules, any type of movement, forget about molecules, it may be an object, it may be human being, animal, or anything. Whenever we move, we always take the help of the kinetic energy. All right. So please remember that we are going to discuss maybe after 1 or 2 days. We'll find this kinetic energy is directly proportional to the temperature. Whenever you supply heat, the kinetic energy increases. When the kinetic energy increases, the molecules gather enough energy to move around. But why they could not move before? Because they are being intermolecular forces of attraction were strong enough to hold them together. When you supply energy, this molecule gain energy, they want to move away from each other. When they move away from each other, the gap between the atoms or molecules in the solid increases, and thus they can start moving. In that process, solid becomes liquid, and when you heat it further, you find the attraction disappears. In this case, you will find atoms and molecules spread away from each other, and they go to the vapor state. So please remember, the thermal energy, okay, is inversely proportional to the intermolecular forces of attractions. Clear? This chapter is very easy, and you have this thing you have already read in, I don't know which class, maybe 9 or 10. All right. So now we'll go for gaseous. We'll write here gaseous states of matter. No, so I write gaseous. Right now, yeah. of the three states of matter. The gaseous state is simplest and shows greatest uniformity in behavior. The gases show almost similar behavior, that you know it. Almost similar behavior irrespective of their physical and chemical nature. What is the meaning of this? Meaning means whether I have taken noble gases which are chemically inert, whether I have taken halogens, whether I have taken hydrogen, oxygen, nitrogen, all of them, okay, they behave similarly. But that will not happen in case of solid and liquid. Their behavior will be different from each other. Clear? So they exist. Let us know something little more. There are 11 elements which exist as gases under ordinary. Please remember, this is an extra information I have given you. Huh? Out of so many elements are present in our periodic table, 11 of them exist in the gaseous state. 11. What are those? See, all noble gases. How many noble gases are there? Helium, neon, argon, krypton, xenon, radon. 6. Then we have fluorine, chlorine. 8. Then we have hydrogen, then nitrogen, then oxygen. All right. So they exist in the gaseous state under ordinary condition. Ordinary condition means atmosphere pressure will be 1 atmosphere or 1 bar, and temperature should be at 200 at 73 Kelvin. They are going like this. So you should know all this. Then the general characteristics. General characteristics of gases. Okay. So what are those? These are highly compressible. Okay, you can compress it. They are highly compressible. Second, gases expand without limit. To any extent they can expand, that you know. Suppose you have evacuated all the air from your room and fill some gas in a small balloon and open it in the room. That whatever amount of the gas present in a small balloon, moment to open it, it is going to occupy the entire room. So they can expand to without limit. Gases exert pressure on the walls of the container uniformly. If you measure the pressure inside your house, in all room, you'll find this pressure is same. In all directions. 4. Gases diffuse rapidly through each other. To form a homogeneous mixture. Diffuse means when it passes through a small hole. Right. The volume and the shape of gases are not fixed. See, this is the difference between solid, liquid, and gas. Solid has fixed shape and fixed volume. Liquid has fixed volume but doesn't have fixed shape. And the gases, they do not have either fixed shape and fixed volume. But what is common with all the 3 states of matter? The common is that their masses remain same. All gases obey certain laws called gas laws. So it doesn't depend upon the nature of the gas. All of them are going to follow.
Sir, done.
Okay. Now, now we'll find the gaseous laws depends upon, or the property of the gas depends upon 4 factors. The properties sorry, I should write physical properties. Of gases depend upon 1. Amount of gas, which you can say, or moles of gas. Second, pressure. Third, volume. And fourth one is the temperature. Okay. So, I'll remove the bracket and I'll put the symbol there, N, P, V, and T. This is N. My handwriting is very bad. You may feel it is H. So now we are going to study the interrelationship. So we are going to study their interrelationship. You do this portion you don't write. Everything you don't be written. Interrelationship. That is, how do they vary? That is, how do they vary with change of the other. This portion don't write. See, in one experiment, we can study the variation of any of these 4 factors with other. 4 we cannot study together. See, you have seen that at a time we cannot measure more than 2. We can keep, if we change one, we'll see the effect of other. Then in that case, as properties varies on 4 of them, what should you do? So in that case, you'll find we have to keep the other two constant. If you keep the other two constant, then we can change the, if you want change one, we'll see what is the effect on the other. All right. So now we are going to do it. Then we'll do first one. Okay, I'll write here now gas laws. Okay, now we'll do here pressure, volume, relationship. This one you know it very well. What do you call this gas law? We'll call it Boyle's law. So in that case, what you have to do? Here we'll keep here. What are the things you have to keep constant now here? We'll keep constant N and T. So we'll write now here N and T kept constant. So what you will find in that case? You will find that if you keep this thing constant, if I increase the pressure, the volume decreases. That you have studied all in school.
Excuse me, sir. Excuse me, sir.
Yes.
So after the physical properties of gases depends upon. So what is the first point?
Amount of gas or moles of gas.
Thank you, sir.
So in that case, in my definition, I have to write this one or statement. So what should I write now here? For a given amount of gas. See, moment I say given amount of gas means I fixed this one. At constant temperature. That is, I have fixed this one now. Pressure is inversely proportional to the volume. So what will write now here? P is inversely proportional to volume. Or what I can write that you know P is equal to K into 1 by V. Okay. So this is right equation 1. What you can write now? Where K is the proportionality constant. You will find in science, everywhere proportionality constant, most of the cases we write K. Out of so many English alphabets, why do you put K? See, initially, these scientific studies, whatever is made, irrespective of the country, most of them are being, all the symbols were being used from Latin or you can say Greek. So in Latin or Greek, the spelling of constant starts with K. Because of that, K is being written. Even in German language also, constant spelling starts with K. So we can write this one. Or what we can write now here? We can write PV equal to K. All right. Now, in your book, they have mentioned, we write it like this, that therefore, okay, we will write it. P1 V1 is equal to P2 V2 is equal to P3 V3 and like this. Why should I write like this? I've done for this. Why should I write like this? Because any experiment, I told you at the beginning in the first chapter about accuracy and precision. When the question of accuracy comes, suppose someone has done an experiment and you have repeated it. So you always want their result should be closer to the reported one. If it is same, you said you are perfectly correct. If it is less or more, then you say it's not correct. Or you call it inaccuracy. Or we try to find out that what is the percentage of error. All right. So this is on when we have done this experiment, when we multiplied this, we got a value. So for this one, whatever the value we've got, we have got the same value for this, same value for this. So in that case, because of that, this is the experimental result. We have written like this one. All right. So therefore, what we can write now? P1 V1 is equal to P2 V2. That is now you can theoretically predict. If you know three of them, you can predict the fourth. Or you can write it like this also, that P1 by P2 is equal to V2 by V1. Okay. So if you know these two and this one is the initial one, then you can find V2. If you know these two and this one, you can find out P2. So this is called the Boyle's law. Okay.
So done.
Okay. So we have done an experiment by the variation of pressure on the volume, and we have got a relationship. This relationship is known as Boyle's law. Then second one is the temperature volume relationship. That you know it, we call it what? Charles law. What we have to do? We keep constant now here. We have to keep amount of gas and pressure constant. Here I'm not going to write directly the relationship or definition of Charles. We'll say see here, we are going to do the graph of Boyle's law. Graph. See, this is the pressure axis and this is the volume axis. In that case, what you find? When the pressure increase, volume decreases. So, this is the graph that you are going to get. In this case, what is the condition? Condition is what? N constant and T constant. So this graph is called pressure volume isotherm. Please remember, these graphs are called pressure volume isotherm. Why? Because you have T cap T constant. Now, this graph, if suppose it is like this volume, and here it is 1 by P, inverse of pressure, you will find this graph will be like this. This is also called isotherm, pressure volume isotherm. See here, because we find that the pressure increases in Boyle's law. We say that pressure is inversely proportional to the volume. Okay, we say pressure is inversely proportional to the volume. But mind it, pressure is directly proportional to what? Inverse of volume. Pressure is inversely proportional to the volume, but pressure is directly proportional to the inverse of volume. Because of that, you find the graph is this one. All right. But again, we found that PV is equal to P1 V1, P2 V2, P3 V3 equal to what? Equal to K constant. So if I plot this graph, what you are going to get? Okay. So in that case, say it is PV. I have put the product PV here, and here the pressure. In that case, we'll find this graph is like this. So these are all the isotherm. Please draw. Graph.
So done.
See this graph now. if I draw it in this way also, P and inverse of V, dear, this also will be same. In entrance exam, many of the graphs are being given. As we do not study graph, unnecessarily you lose mark. But see in graph, if you just know it, it's a matter of only few seconds you can score 4 marks. You don't have to do any calculation.
Sir, done.
See, many things you might have seen that I am teaching you too much of extra is only because for your entrance. Okay. Now, dear, I like to tell you one thing. I don't know whether you have any idea of the log. See, we say here PV is equal to K. If I take logarithm here, logarithm will find if I take log on both sides, then log PV is equal to log K. Okay. When you take logarithm of a product, in that case you will find is log P plus log V is equal to log K. All right. Now, if this is being plotted in this way, see, it is up to you whether you should write or not. Extra thing I'll never force on. So if I plot it now here, log P and log V, you will find here the graph is like this. This type of slopes are called negative slopes, and if this type of slopes are called positive slopes. Okay, Charles law and all other laws I'll do in some other day. That day already I have taken so much extra for you and you might have missed your school classes. Okay. So wish you a good day.
Thank you, sir.
Welcome.
Thank you,
Welcome.
sir.
Thank you, sir.
Today one